The equal variance t-test is an independent t-test and it is used when the number of samples in each group is the same or the variance of the two data sets is similar. So the samples of independent t-tests are selected independent of each other where the data sets in the two groups don't refer to the same values. T-test is a statistical test that is used to compare the means of two groups. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 5 of Unit 5, we will be having a discussion on the paired sample t-test. So the correlated t-test or the paired t-test is the dependent type of test and it is performed when the samples consist of matched pairs of similar units or when there are cases of repeated measures. For example, there may be instances where the same patients are repeatedly tested before and after receiving a particular treatment. Each patient is being used as a control sample against themselves. So, this kind of a paired sample t-test, it is used when we have the same sample or when we are having a comparison of the same sample. So, this method also applies to cases where the samples are related to have matching characteristics like a comparative analysis involving children, parents or siblings. So, this can be applied. This kind of a paired t-test is applicable where we have matching characteristics. That is, when we have a comparative analysis of the children, the parents and the siblings. Then, the formula for computing the t-value and the degrees of freedom for paired t-test are t equals mean 1, mean 2 divided by standard difference divided by root of n, where mean 1 and mean 2 are the average values of each of the sample and S is the standard deviation of the differences of the pairs, the sample size, the number of paired differences, n minus 1 is the degrees of freedom. Next, the equal variance test. The equal variance t-test is an independent t-test and it is used when the number of samples in each group is the same or the variance of the two data sets is similar. So, the formula used for calculating the t-value and the degrees of freedom for the equal variance t-test is, so t-value will be mean 1 minus mean 2 divided by n1 minus 1 into variance of 1 the whole square plus n square minus 1 into variance of 2 the whole square divided by n1 plus n2 minus 2 into root of 1 by n1 plus 1 by n2. So, this is the formula we have to use in order to calculate the t-value. So, mean 1 and mean 2. What do we mean by mean 1 and mean 2? It is the average values of each of the sample sets. So, the variance means variance of each of the sample sets n1 and n2 and the number of records in each of the sample set. Next, the unequal variance t-test. The unequal variance t-test is an independent t-test and is used when the number of samples in each group is different and the variance of the two data sets is also different. So, this kind of unequal variance t-test, it is used when the number of samples in each group is different and also when the variance of the data sets given also is different. So, this test is also called as the Welsh t-test. The formula used for calculating t-value and the degree of freedom for the unequal variance t-test is degrees of freedom equals variance 1 the whole square divided by n1 plus variance 2 the whole square divided by n2 the whole square whole over variance 1 the whole square by n1, again it repeats, divided by n1 minus 1 and n2 minus 1, where variance 1 and variance 2 are variances of the each of the sample sets. The unequals, where variance 1 and variance 2 are the sample sets, n1 and n2 are the number of records in each of the sample set. Following flowchart can be used to determine which t-test is used to base the characteristics of the same sets. The key items to consider include the similarity of the sample records, the number of data records in each sample set, and the variance of the each sample set. Next, so if you can see the table here, are the two sample sets same or related? If it is yes, then we can use the paired t-test. Then, if the two sample sets, they are not same or related, then it is a no. Are the two sample sets of the same size? If it is yes, then we can use an equal variance t-test. Then, if it is a no, then do the same sample sets have the same variance? Then again, if they have the same variance, then we can have the equal variance t-test. Then if they don't have the same variance, then we can use this unequal variance t-test. So with the help of this table, we can be able to know whether when to use the paired dependent test, equal variance independent test, unequal variance independent test. So we will be able to know when to use which test. The next, what is an independent t-test? So the samples of independent t-tests are selected independent of each other, where the data sets in the two groups don't refer to the same values. So an independent t-test is used when the data sets do not refer to the same values. They may include a group of 100 randomly unrelated patients split into two groups of 50 each. One of the groups becomes the control group and is administered a placebo, while the other group receives a prescribed treatment. This constitutes two independent sample groups that are unpaired and unrelated to each other. So when can we have an independent t-test? So this they have given an example here. So when you are selecting at random 100 patients at random and divide them into groups of 50 each. So one of the group gets a placebo, whereas the other group gets a prescribed drug, and then we can have this independent t-test. Next, what does a t-test explain and how they are used? A t-test is a statistical test that is used to compare the means of two groups. So groups of two means we can use it for comparing. It is often used in hypothesis testing to determine whether a process or treatment has an effect on the population of interest, or whether two groups are different from one another. So this is usually used for treatment. What is the effect of the treatment of that drug on that particular sample, and also whether the two groups are different from one another. Then what is the chi-square test? A chi-square test, it is a test that measures how a model compares to actual observed data. The data used in calculating a chi-square statistic must be random, raw, and mutually exclusive, drawn from independent variables and drawn from a large enough sample. For example, the results of tossing a fair coin meets this criteria. So, a chi-square test. What is a chi-square test? It is a test that measures how a model compares to the actual observed data. Now we have the observed data and then we have the model. Now this we will be having a comparison between the model and the observed data. So it is used the data used in chi-square statistics. So the whatever the data you are using for the chi-square statistic, it must be at random. Whatever you are using, it should be collected at random, it should be raw and mutually exclusive, then drawn from independent variables. Now the best way to describe all these data is it should be raw, it should be random, it should be mutually exclusive, means the tossing of a fair coin. So when you toss a fair coin, it is random, it is raw, it is mutually exclusive, and it is also drawn from independent variables. So all these criteria are met by the tossing of a fair coin. So this tossing of a fair coin, it can be used for a chi-square test. Then chi-square tests are often used to test hypotheses. The statistic compares the size of any discrepancies between the expected result and the actual result given the size of the sample and the number of variables in the relationship. So they are often used to test the hypothesis. So it compares the size of the discrepancies. So what is the expected result and what is the actual result? So it will have a comparison and it will also tell us what is the degree of difference between the two. For the test, degrees of freedom are used to determine if a certain null hypothesis can be rejected based on the total number of variables and the samples within the experiment. So, for these tests, degrees of freedom are used to determine if a certain null hypothesis can be rejected based on the total number of variables and samples within the experiment. As with any statistic, the larger the sample size, the more reliable the results. The next, a chi-square. So this is the symbol for the chi-square statistic. It is a measure of the difference between the observed and the expected frequencies of the outcomes of a set of events or variables. So what is the observed and what is the expected frequencies? You can have it is a measure of the difference between the two, and it is useful for analyzing such differences in categorical variables, especially those nominal in nature. So all those nominal variables we can use this chi-square for her comparison. So it depends on the size of the difference between the actual and the observed values, the degrees of freedom and the sample size. It can be used to test whether two variables are related or independent from one another. Then it can also be used to test the goodness of fit between an observed distribution and a theoretical distribution of frequencies. Next one, what does a chi-square test statistic tell you? So there are two main kinds of chi-square test. The test of independence, which asks a question of relationship such as is there a relationship between the student gender and course choice, and the goodness of fit test, which asks something like how well does the coin in my hand match a theoretically fair coin. So there are two main kinds of chi-square test. So that is the test of independence, and second one is the goodness of fit. The second test is the goodness of fit. Now, what is this test of independence? The test of independence, for example, is there a relationship between student gender and the course choice? Now, will the student gender affect the choice of the course? Suppose the student is a boy or a girl. So, if it is a boy, they go in for engineering course, and if it is a girl, they go in for the MBBS course. So, we can have a study of whether the gender of the student makes a difference in the choice of the course. Then, next one is the goodness of fit. So, the goodness of fit, it will give answers to how well the coin in my hand match a theoretically fair coin. So, how is the coin in my hand different from a fair coin? we can have this goodness of fit test. Then chi-square analysis is applied to categorical variables and especially useful when those variables are nominal, where order doesn't matter, like the marital status or the gender. Next is independence. When considering student gender and course choice, a chi-square test for independence could be used. To do this test, the researcher would collect data on the two chosen variables, the gender and courses picked, and then compare the frequencies at which male and female students select among the offered classes using the formula given above and a chi-square statistical table. So, when we are having this, for example, the same example is repeated here. So, we have to consider the gender of the student and the course choice. So, when you have this both, so you will be having a comparison. So, when you have data relating to the gender, whether it is the boy or the girl, and then course choice, whether it is the engineering or the MBBS. So, chi-square test of independence could be used. So, we can have when we need to have a comparison, we can make use of the chi-square test. So, with the help of the formula given and also with the chi-square statistical table. So, the chi-square formula is there, and with the help of the chi-square statistical table, we can come to a conclusion whether the gender affects the course choice, what course of the education the student wants to take. Next, if there is no relationship between gender and course selection, that is, if they are independent, then the actual frequencies at which male and female students select each other offered course should be expected to be approximately equal. Now, if we come to a conclusion that the gender does not affect the choice of the course of the education, then what will happen is, then if we say that they are independent, then the actual frequencies at which male and female students select each offered course should be equal. So, whether it is engineering or the medical field or any other, whether it is BCom, BBA or BCA, if the gender is independent of the course selected, then we can expect that the frequency should be approximately equal, or the proportion of the male and female students in any selected course should be approximately equal to the proportion of male and female students in the sample. So, the frequencies will be more or less equal when we say that proportion of the male and female students and the proportion of the course choice both should be equal. A chi-square test for independence can tell us how likely it is that random chance can explain any observed difference between the actual frequencies in these data and these theoretical expectations. So, the test for independence, it will tell us that the random chance can explain any observed difference between actual frequencies and the theoretical frequencies. So, the actual frequency is actually whatever you have collected, and the theoretical. So, you are assuming things that the gender of the student will affect the choice of the course. So, when you have a comparison between the two, we can know exactly. So, for this comparison, we need the chi-square test. So, with this, we come to the end of this session. Hope you have all followed it. Thank you.